I'm Russ Briall with the Shroud Report Education Project, and welcome to the Shroud Report. Now, today my guest is Pete Schumacher. Now, Pete, thank you for coming.
My pleasure, Russ. Nice to be here.
Now, you are a specialist in images.
Well, image processing, remote sensing, collection of images. We try to help people solve problems with imagery, from satellites or video cameras or various kinds of sensors.
Now, you've been involved in this kind of work for years and years.
Oh, a long time. I started in 1972 at a place called Interpretation Systems Incorporated in Lawrence, Kansas, and have been in the field ever since.
Okay. Now, your first encounter, and the reason that you're here on the Shroud Report, is with a special computer that is known as a Vp8 Image Analyzer.
That's correct.
And maybe you can explain what that computer does and did.
Be glad to. Basically, the Vp8 Image Analyzer was an analog computer, not like the digital computers we have now today. And to that extent, it was what we might call a dumb computer. It did a few simple processes, and if you put a video image into the machine, it would automatically process the image in a particular way and then make the output instantaneously. So we didn't do an analog to digital conversion or work with it with a laptop computer like we would today, and of course we could do more sophisticated things today, but the beauty of the Vp8 Image Analyzer was its simplicity and its speed.
So, in other words, the information that you got from it is what it is. You couldn't really manipulate it or make it say something that wasn't there.
That's correct. Basically, what you put in created whatever came out.
Okay.
The Vp8 Image Analyzer,
I think you have a picture right here. Okay.
We have a unit that was used to do all kinds of interesting photography with Landsat satellite photographs and various aerial photographs as well, and we were trying to look at the Earth's resources with these to determine the health of soils and the condition of crops and where riparian zones were and locate water resources and things of that nature. We also found that there was a particular display that this unit had that was very good for tracking linear features in the Earth's surface. And this would be like a fault line, for example. And of course, we're all very interested in where are the fault lines because we're worried about earthquakes.
Right.
So one of the things that we did was we followed these linear features using a feature of this particular instrument, which was called the Isometric Display.
Okay.
And basically the way it worked, if we took a look at our globe from space, and this photo here is courtesy of NASA, we would get a picture then, we would think, that is round.
Right.
And maybe looks like a sphere, like a basketball, because we know from Columbus that that's what should be. And the way the Vp8 Image Analyzer works is that it would scan a horizontal TV line in the picture, which is what we see in this slide.
Right.
And bright things went up and dark things went down. And if it was some shade of gray in between, then it would be at an elevation in between.
Okay.
If we took all of the lines in the picture and we looked at them all together at the same time and tilted them back, we would get what is called an isometric display.
So how many lines would be in this picture here?
Well, there are 480 horizontal lines that are visible in this scene.
Okay.
And so there are 400 lines that go from left to right across your screen, basically. And there are, of course, then features across each one of those lines that represent brightness changes.
Right.
Up being bright, dark being down.
And what we're looking at here is the cloud cover from that picture we saw from space.
That is correct. And the net result, of course, is not a sphere, not a basketball.
No.
It's not a three-dimensional display.
Because the photograph itself is not three-dimensional, correct?
Well, the photograph itself is only two-dimensional. That is correct.
Right.
And brightness values in this image have nothing to do with elevation.
I see.
If we thought for a moment about maybe a bright white peak on a mountain where it's snow-covered, and then maybe there was a rock sitting on top of that mountain, then where the mountain was bright white, it would be up. but where the black rock was, it would be down.
In terms of that isometric line, that a graph, where it was white,
correct.
the line would go up. Where it was dark, it would go down.
And so if I came up for the nice white snow-capped peak,
right,
and came to where the rock was that was actually above the snow, the rock being darker than the snow would look like a hole in the snow instead of like it was sitting on top.
I see. So even though it's higher, it looks lower.
That is correct.
Okay.
And that's a simple way to state that with the Vp8 Image Analyzer, and as we see in the slide picture, we don't get a three-dimensional result.
Okay.
Brightness doesn't have anything to do with dimensionality, height or depth.
I see. Okay. Okay.
But when we put a shroud slide, say for example the face image,
right,
into a Vp8 Image Analyzer, the result we get is quite a bit different.
So there's no distortion. What I'm seeing here is an image which appears to be three-dimensional.
That's right. Where the nose ramps up on the face, like my nose ramps up if I were laying down.
Right.
And where the forehead rounds off and things are in the proper perspective,
They're in their
generally
proper
speaking.
So because it's not based on light or brightness.
There's evidently
it's not
something
based
on the shroud that causes the brightness values in the shroud to produce a three-dimensional response when we scan it with a Vp8 Image Analyzer.
Okay. Okay.
I think probably the best way to illustrate this, I'm going to back up one slide, and we're going to look here at the shroud image. On the left in this image, we see the photographic positive. That's the way the shroud looks if we take a picture of it.
Right.
When we develop the photographic negative, however, that's the picture we see on the right.
Mm-hmm.
And kind of like Secundo Pia, when he took his first photographs, we found out something rather startling about the Shroud of Turin image. Secundo Pia noticed that the shroud image looked easier to see and had more contrast and more detail in the photographic negative form, and he called it a photographic negative.
Right.
Well, when we scan it with the Vp8 Image Analyzer, we get a three-dimensional response back.
And you even see more detail here than you do in what you can see visually on the cloth itself.
Well, we see form.
Mm-hmm.
We see something we don't see when we look at the cloth. The cloth is a two-dimensional image. The photograph that we're taking this image from is a two-dimensional image. But the grayscale information is causing a three-dimensional result.
So it's the grayscale information, the
actual data on the shroud.
The data, you called, I remember talking to you before, and you called it a spatial database.
The shroud itself is basically a spatial database.
And
in other words, it has a form, a two-dimensional form, and within that form it has image information and stain information and fold mark information and all kinds of other information. And when we have a two-dimensional space that contains particular information that may be physically located, we call that a spatial database.
Okay.
So the shroud itself is a spatial database.
Like a topographical map.
More or less like a topographical map. In this case, because now we have elevation information as well as bright and dark or red or other colors or fold marks.
And what creates that spatial information then is what you call the grayscale, meaning I've heard it described that the reason that this phenomenon seems to occur with the shroud, this three-dimensionality, if you will, is that it appears that the closer the cloth was to the body, the darker the image.
Well, now that's one theory.
Okay.
So we now get into what we call theories.
Okay,
right?
okay.
And so one scientist might pose that the reason that the information has a three-dimensional characteristic is because its proximity, its closeness to the body that was inside of it. Another person might say, well, I think it was some sort of thermal radiation or some sort of electromagnetic radiation or some other type of energy. And we don't know that. We don't know what caused the image. We only know the result of the processing.
We just know the results. We just know that for some reason the shroud image contains data that indicates distance information, height, and somehow related to the grayscale information.
That's correct. And we don't know why.
Wow.
And we don't know exactly how. Now, it's true that this occurs on both the front and back of the image. If I take a picture of a human being, as we're showing here, and I process it through a VP-8 Image Analyzer, we can see that it no longer has a three-dimensional characteristic. The shadow of the person's nose is cast to the right-hand side of the nose, and therefore it looks like the nose has a large dip or groove in it. Also, because the flesh tones are fairly uniform, and the reflectance then of the flesh tones are pretty much the same, they all wind up at about the same altitude, I should say, the same height.
Right.
The eyebrows in this case look like grooves because the eyebrows of this person happen to be darker than his skin tone.
And because they were darkened, then like on that graph that you showed, they go down.
That is correct.
Okay.
And so when we normally process a normal photograph, we don't get a three-dimensional result. It doesn't happen. It only happens when we process an image from the Shroud of Turin. If we look at artworks from back in the 1600s, for example, this artwork was made, we find out that they don't make a three-dimensional result.
Right.
The results are not anywhere near the same as taking a photograph image of the shroud and processing it, or processing the shroud photographs in a positive or negative form.
Right.
So it's only with the shroud images that we get this reaction, shall we say, to a three-dimensional result. And the result occurs over the entire front and back of the image. And in this slide, this is a positive to negative of the front of the body on the Shroud of Turin. If we process that image, we get a three-dimensional response. And in the upper part of this picture, you can see that the arms have a three-dimensionality characteristic to them. The face, of course, as we saw before. But look at the legs as well. The legs are rounded, and they come up to the knees, and we see a contour there, or a shape, an elevation change, that is particularly unique to the Shroud of Turin. If we look on the back side of the image, we can see a generally three-dimensional characteristic as well, where we can see the shaping, basically, of the back of the shoulder blades, the back of the head, and so on.
What are those lines that seem to traverse?
The large lines that seem to be prominent in the picture, unfortunately, are from the burn marks from when the shroud was in a fire in about 1532. And we know what the cause of those marks are, so they're not part of the image, and it's difficult for us to ignore those when we're looking at the Shroud of Turin image, but they're not really part of the image information. They're part of something else that's an artifact of the fire in 1532, so we have to learn to ignore those.
Right. This is fascinating stuff. I think we're going to take a break right here. We're going to be back with more of this on the Shroud Report in just a minute. Hi, I'm Russ Brialt, and welcome back to the Shroud Report. And today my guest is Pete Schumacher. And Pete, you are an image specialist.
Image analyzing and remote sensing.
And we've been talking about this curious phenomenon of the shroud, this kind of 3D aspect of it, of the image, and you know, I think what most people that I talk to find interesting about the shroud is its mystery. It's just this phenomenal mystery, and it just seems every time I talk to someone on the Shroud Report, the mystery just gets more profound.
I think we are learning more things as our knowledge advances as a society, and I think we had a couple of major jumps in understanding about the Shroud of Turin when Secundo Pia developed his photographs in 1898. And I think we had another big jump in that knowledge when John Jackson and Eric Jumper out at the Air Force Academy and took an image and processed it through a Vp8 Image Analyzer. So I don't know what the next surprise is that the Shroud has in store for us, but it does seem that we seem to be learning in jumps or leaps.
It seem to be these kind of pivotal events when we seem to learn so much more about it.
It does seem that there's something to do with our knowledge, and I believe that that's some sort of a controlled revelation. Maybe when we're ready to understand it and be able to deal with it or work with it, or when we need it as a people, maybe that's when we're getting let to know.
Seems to be tied to technology too, because in 1898 was the beginning of photography.
Very early days of photography.
And that was the discovery of that the shroud is actually a negative image, and therefore what appears on a photo negative is a positive image.
Well, basically that's true. I think I like to choose the words a little more carefully. When I say if the shroud looks better in a negative form, or I can understand it better in a negative form, it doesn't necessarily mean that the Shroud of Turin itself is a photographic negative. That kind of leads us to thinking that, well, maybe it was reflected light like we get with a normal photograph, or transmitted light like we might get with a normal photograph. And such is not the case, because we've proven that with the Vp8 Image Analyzer, for example. There are other characteristics about the Shroud of Turin that kind of maybe hint at being a little bit of the radiography type of an image, like an X-ray type of image, because we can see extension of the bones in the hands clear up into the fleshy part of the hands, up more towards the wrist. And just even that simple little thing suggests that maybe there's some X-ray style imaging in there too. But I hesitate to say that, because then if I say it's an X-ray image, then one would jump to the conclusion that I could make a simple radiograph and get the same results as I have on the Shroud of Turin, which is not true. And it's not really a three-dimensional image either, even though I refer to it when we talk about it on the Vp8 Image Analyzer, that we get a three-dimensional quality back out of the image. It means that there are some properties of the image that, when produced on the Vp8, do produce a three-dimensional result. It's not truly 3D necessarily over the whole image. And so there are some really new discoveries, observations maybe I should say. There's some older observations too that all tend to indicate that there's much more than we've been able to uncover so far. So I think we're still in for a big learning curve on the Shroud of Turin.
Now, you've brought something here to show us. And,
well, one of the things that we hear about, of course, on the Shroud of Turin is that it's some sort of a painting. And of course, we proved it in one way, that the Vp8 Image Analyzer, if we look at a painting, does not produce a three-dimensional result. If we look at something where some light powdery substance has been placed onto the shroud cloth, and this is an old jacket, by the way, that I had, and it just happened to have a herringbone weave in it, and one of the shroud experts saw it and said, gee, you know, I could do some of my tests with setting up microscopes and things like that with this material, because it very closely resembles the shroud.
And that was the end of your jacket.
Sacrifice that thing to science right there. It happened in an instant. So what I did in this is a very simple experiment that anybody can do to prove that the Shroud of Turin image is not with any kind of pigment or stain device of any kind. And the way that we can do that very simply is we put some powder onto this cloth. Now when it is top lit, we can see that it's much brighter where the powder is very lightly there. And it may be very difficult to pick that up on television. I don't know if we can do that or not. I know that if I take my color video camera at home and I accentuate the color amplitudes, the color phase, I can shift that just like you do when you do the tint control at home on your TV set to try to make the colors look the way you want on your TV set at home. We can do that electronically with the processor. But in this very simple case, all we have to do is light up the back of the cloth. And when we do, we note that the threads that are covered by the powdery substance are darker than the threads that are not covered with the substance. And so the net result is a very simple experiment, kind of like when we would take a flashlight and shine it through our palm. I don't know if you've ever done that or not, but it's a fun thing I used to do when I was a kid, because I always liked to look at the interesting formation that was inside my hand. So take a flashlight and I shine it through my hand, and where the bones are, the light won't pass through. Well, the same thing is happening here. Where the pigmentation is, or the other material is, that's going to make it more dense to the passage of light. And so when we light it from the back, the light doesn't get through those threads as well.
Right.
And that proves that it can't be a pigment. Very simple test. Now, on a slide that we have,
so now this is the shroud that's been backlit.
This is the shroud that's been backlit. And here we can see at the cross section in the middle where the arms are, we can very readily see the blood stains.
Right.
On the back of the arms, on the top of the arms, I should say. But we can't see the image.
Right.
And if the image was made of some sort of a pigment, then what would happen in this image is that we would see it much more clearly, because the image of the pigment would be darker than the rest of the fibers that are not covered by the pigment.
Because I'm looking at that image there that's been backlit, and I see the side wound.
Very easily.
I see the blood on the arms.
Very readily.
I see water stains from where the fire was put out.
Very easy.
Obviously, you see the burns. But what you, even down at the very bottom where the feet are, you see some of the blood down by the feet.
That is correct.
But there's no indication of the image of the man.
There's little to none, and I would suggest none. I've not been able to really discern significant
which is just kind of like a visual, easy visual piece of evidence to indicate that there's no pigment on the shroud to account for the image.
If we have a pigment that's dark enough to be seen, as we had even with the pigment that's lighter than the cloth color is, what happens is when we light it from the back, that extra pigmentation causes a
You'll see the darkness.
reduction in the amount of light that's allowed to pass from the back to the front.
Right.
And this is a simple test anybody can do at home.
That's fascinating. Well, I'll tell you what, the mystery just gets more profound, and we'll be right back with the Shroud Report in just a minute. This is Russ Brialt, and welcome back to the Shroud Report. And my guest today, again, is Pete Schumacher. And Pete, this is just a profound thing, and as I mentioned before, every time I talk about it, I get more mystified by it.
It's a very interesting puzzle.
All that we've been talking about today, the fact that you showed how you backlight the shroud from behind and no image appears, or the fact that or the evidence from the Vp8 Image Analyzer that it's like a spatial database is what you called. What does that lead you to believe?
Well, I believe, of course, that this is the burial cloth of Jesus Christ. I think one thing that is universal in acceptance, certainly with the majority of the scientists, is that at some time or another there was a body inside that cloth. Otherwise, we couldn't get the detail, we couldn't get the shape, we couldn't get the forms, we couldn't get the responses that we're seeing in this Shroud of Turin image. And I guess the good news is there's no body there anymore.
Right.
So we have a picture, but we don't have the body itself. And the picture is remarkable and very unique.
It is a profound image, and it certainly makes you think, doesn't it?
It certainly does. There's no other image like it that made by an artist or by any other means, and there's no record of any other work like this. So it's hard to believe that somebody in the medieval times might have contrived something to make something that would be photographically negative in 1898, some 650 years after the known records of the Shroud of Turin's existence, or that certainly they would make it so that it had a three-dimensional grayscale encoding when scanned by a Vp8 Image Analyzer, which didn't exist until 1972.
Right.
So very difficult for an artist to contrive something like that.
Certainly.
Quite a unique image.
Yeah. Thank you very much for joining us here on the Shroud Report.
My pleasure.
And once again, we look forward to you joining us next time on the Shroud Report. Thanks for tuning in.